Hey everyone, sorry I can't be in today. This is Nova. Maybe some of you have met Nova before. But we're going to do a little screen recording for you for the assignment for today. So it's all about remembering trig functions. The reason for this is that we're talking about vectors. We're going to be handling vectors, but we need to be able to know how to look at side lengths and figure them out if we know angles, or vice versa. So remember that components are your friends. Right? If we have an original vector here, we can break it down into an x component and we can break it into a y component. And so we're going to be able to deal with that. X and y components are both here forming that right triangle with the original vector by definition. So we're going to do some kind of right angle trigonometry using this triangle. And the first thing that we're going to be looking at is we're going to be looking at the Pythagorean theorem. The reason for this is that the assignment that I've given you today is called Remembering Basic Trig Functions. So Rob has given it to you, and hopefully you're already looking at it. Maybe some of you have already started it, but if you need a little help, that's what this video is about. So we're talking about the Pythagorean theorem to begin with, and it's very straightforward. There's no special things when it comes to physics overall. So I've got a squared plus b squared equals c squared. I've got these three sides. C is always the longest length of that triangle, right? The hypotenuse. So if I square A and I add in the square of B, that's going to equal the square of C. If I'm solving for this, though, I will need to have square roots. So don't forget that. Different calculators look different when it comes to square roots. Mine that I'm getting on the Mac here has the little square root function with the 2 in the corner, but they don't always have the 2. Sometimes it's just the square root. Are you telling them all about it, Nova? So that's what we've got here. So if I know A is 10 and I know B is 4, we can just square those two. The big thing here is that we now have a meters. That's different from your math classes. So 10 meters squared is 100 square meters. And 4 meters squared is 16 square meters. So add those two together, and then take the square root of those, and you can go ahead and get that last side length, C. That length C is going to be in meters, because you took the square root of meters squared. So keep that in mind. There's 3 problems here. They should be pretty straightforward. The next set of problems that are over here, the sine, starting at the top using sine, cosine, and tangent. This is important. So those of you who have ever seen the movie Finding Nemo, you'll know my trick. So in my brain, when I think sine, cosine, and tangent, I think this. I want you to say it with me in the voice of Finding Nemo from the tank fish. We have this chant, so here we go. Sokatoa, 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 shark bait, ooh-ha-ha. That's right. Sokatoa, 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 shark bait, ooh-ha-ha. Right? Right. So with that, it means that we're talking about ratios. This is just a nice little trick to remember how this goes. So stands for the sine is equal to the opposite over hypotenuse. So if I've got this triangle right here, sine is it's just a function in trig where we can take the sine of an angle. So here's where that angle might live in that right triangle. It's either going to be down here or up here, not the 90-degree one. But it's going to be the sine of this angle is the opposite, so that's the one way far away from it, divided by the adjacent. So you can go ahead and put together an equation like that and be able to do so. On these first problems, though, you're not going to need that at all. You're just going to need a calculator to be able to type in sine of 45. Make sure you're in degrees and it'll work out. Or cosine of 45. So if I'm over here and I say, hey, I've got 45, I'm going to hit sine and it's going to pop me out an angle. Or excuse me, an amount. This is the ratio. The ratio itself is nothing more than, right, what the sine of 45 degrees. So the opposite divided by the hypotenuse would give you that number of 0.707. So that's the starting point. You're going to do a lot of these calculator-wise. When you get down here and multiply by it, remember that your answer is going to be in meters, because if it's 15 meters times this number here, you are going to end up in meters. So those are the way those work. If you have a missing angle like this one here, though, we can go ahead and use a different form of sine, cosine, and tangent. So sine is here, so opposite over hypotenuse. Cosine, adjacent over hypotenuse. So adjacent is the one touching the angle. And we can go ahead and do that. And then tangent is the opposite divided by the adjacent. But If we are missing an angle and we want to find the angle out, we have to move into something called inverse trig functions. So I've included those down here. They have the -1. Don't forget that when you're working on your calculator. If it doesn't show here, maybe it's second function, which mine is. I've got a second function sign right down there. And I work on that here, and I can go ahead and type that into my calculator. So if I've got A is equal to 10 meters, and I've got B is 2 meters, here's A at 10, here's B at 2. Notice that this triangle doesn't change. I'm not changing it. So we're just sticking in numbers related to some sort of triangle here. And we're solving for theta. We can go ahead and put those pieces in, 10 and 2 for A and B. So in this case, 10 is opposite of the angle, and 2 is adjacent to the angle. So this is opposite and adjacent. So if I'm doing theta, the opposite and adjacent one is tangent, specifically the inverse tangent. So I can plug these in. So if I take the inverse tangent of opposite over adjacent, opposite being 10, adjacent being 2, so 10 divided by 2 meters. 10 divided by 2 meters, right? So 10 divided by 2 meters, that apparently is the timer. No worries at all. So 10 divided by 2 meters gives us working it, and we can get that as 5. So I would go and type into my calculator 5, and then I need to take my inverse tangent of that, and it's going to give me an angle out, so the angle that I walk away with. So that's the angle that I'm typing in here. Okay, so that's for the same for each of these. Keep an eye on what side lengths you have and which trig function you need. Over here, I'm just mixing and matching a little bit, so trying to find out these last pieces using your trig functions and your inverse trig functions. The second half of the assignment down below is all about taking these and turning them in, or looking at vectors specifically. Part A is what you were doing on the whiteboards the other day. Nothing different about it, just add them graphically. So A is 10 meters north, so going straight up. B is 3 meters northeast. When I say northeast, I mean perfectly northeast, so 45-degree angle, right, as you're doing. So how far is this from home if we go 10 meters north and then 3 meters northeast? Add the vectors graphically, nose to tail, and find the resultant graphically. You don't have to go ahead and do any numbers there. However, when we come down here to B, C, and D, I am asking you to find the x and y components of A, which is a little tricky because it's just going straight north, so think about what that would mean for each of those components. B is a 45-degree angle, remember, so x and y components for that 45-degree angle. And then add the x and y components, so add the two a's to get, or the two x components together, and then the two y components. And then last but not least, please draw the kind of resultant vector magnitude and angle from the x-axis for your resultant vector. So I wish you luck. This is the assignment. Do ask questions of each other, and I'll be back tomorrow to talk to you. All right, have a great day, and let's see if I can figure out how to turn this darn thing off. Say bye-bye, Nova.
Bye-bye.
Thank you.